All right, welcome back. We're going to continue. This is part 2 of Introduction to Sequences. I'm going to give you another problem. So the numbers are 1, 3, 9, 27, 81, blank, blank. Might need a calculator for this one. Let's see if you can find the missing 2 terms. Alright, so what's going on here? Well, am I adding, I guess if you were trying to approach this problem, you might first look at, are we adding the same number every time? And clearly we're not. You add 2 to get 3, but then you have to add 6 to get 9. So we're not adding the same number every time. So then I would look at, well, are we multiplying by the same thing every time? Well, you would need to multiply 1 by 3 to get 3. So then if you multiply 3 by 3, you get 9. If you multiply 9 by 3, you get 27. So that's it. We're multiplying by 3 every time. So to get the next 2 numbers, you're just going to start with 81 and multiply by 3. And that gives you 243. And then multiply that by 3, and you get 729. So this is 243, and this is 729. All right, what are the rules for this? So let's look at the explicit rule. You start off the same way. It's a sub n equals the first number, which is 1. What are you doing to it? Well, you're multiplying by 3, so times 3, like so. How many times do I have to multiply by 3 to get to the nth term? I need to multiply it n minus 1 times. Well, repeated multiplication is exponential. So that's n minus 1 power. Unlike earlier when we did repeated addition, which it is represented with multiplication, this time we're doing repeated multiplication, which is represented by an exponent. It's kind of like if you did 3 times 3 times 3 times 3, which you could write as 3 to the 4th power, right? So repeated multiplication gives you an exponent, as opposed to 3 plus 3 plus 3 plus 3. That's repeated addition, which is just 3 times 4, right? 3 4 times. So we see the difference here between repeated addition, which results in exponents, and repeated multiplication, which results in exponents, versus repeated addition, which results in multiplication. So we have an exponent here. Like before, I'm going to try it out and see if the rule works. So I'm going to see if the first, second, third, fourth, fifth number really is 81. So a to the 5th, for the 5th number, is 1 times 3 raised to, n is 5, so I put a 5 there, 5 minus 1. So to simplify that a little bit, I would do 1 times 3 to the 4th, and a to the 5th is in fact 81. 3 times 3 times 3 times 3 is 81. 3 raised to the 4th power is 81. So it works. Check it out. So that is the explicit rule. What is the recursive rule? Well, remember with the recursive rule, there's 2 parts. You have to give a starting number, so a1 equals 1. And then you have to give the rule. So a sub n equals a sub n minus 1. What are you doing to it? Well, you're multiplying by 3. You could put it here times 3, but typically we write it in the front, so 3 times a sub n minus 1. So that is your recursive rule. This is recursive, and this is explicit. All right, so you try one. Yeah, so let's do, let me see. We'll do 5. No, let's do 12. 12. And then 6, and 3. And then 1.5, comma, blank, comma, blank. So go ahead and find the two missing terms and see if you can find the explicit rule and the recursive rule for this one. All right, so what's going on here? Well, it looks like it's going down by half, right? 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 2 is 1.5. So then we would want to do 1.5 divided by 2 next, and so on. Well, what do you multiply by? Because we don't want to divide by 2. We want to multiply by something. So what do I multiply 12 by to get 6? The answer is a half, right? If you multiply 12 by a half, you get 6. Or you could say we multiply by 12 up 0.5. So I could write the explicit rule as 12, because that's the starting number, times 0.5 raised to the n minus 1. Now let me go ahead and find those two missing terms also. So I need to put in 1.5 times 0.5, so that's 0.75, and then times that by, multiply that by 0.5, and I get 0.375. This is 0.75, and this is 0.375. All right. So now we have the explicit rule. And over here I'll do the recursive rule. So A1 is 12. And A sub n equals 0.5 times A sub n minus 1. Okay, so what I'd like to do now is give you a rule, and you tell me the first 5 numbers that the rule generates. So I'll do one first as an example, and then I'll give you a couple. All right, so number 6. Let's say I have A sub n equals 3 plus 4 times n minus 1. All right, so what I want you to do is to find, I'll give you a chance to do it by yourself first. So find the first 5 terms. That's 3, 4, 5. All right, so go ahead and see if you can find what those are. All right, what we can do is just plug into the formula here. So first you're going to plug a 1 in, and I get 1 minus 1 is 0, right? 0 times 4 is 0. 0 plus 3 is 3. That makes sense. The first number is always that number right there in the front, isn't it? All right, then I plug a 2 in. So 2 minus 1 is 1. 1 times 4 is 4. 3 plus 4 is 7. So the next number is 7. All right, if I plug a 3 in, that's going to be 2, right? All that's 2. Times 4 is 8. 8 plus 3 is 11. So as you can see, we're just adding 4 every time, and that's what the rule says, right? You start with 3, you add 4 n minus 1 times. So I'm just going to add 4 again. That's going to be 15. Add 4 again. That's 19. That's it. All right, see if you can use the rule to find the 100th number. Go ahead and do that. All right, so to find the 100th number, we put 100 right there. That's 99. I don't know what 99 times 4 is, but I'll just put it in exactly as it looks. So we have 3, clear that out, 3 plus 4 parentheses 100 minus 1, and I get 399. All right, let me give you another one. Find the first 5 terms. This time I'm going to give you a recursive rule. So A1 is 4, A sub n is negative 2. Negative 2 times a sub n minus 1. All right, so that's the rule. Go ahead and find the first 5 terms. All right, so what is the rule saying? It's saying start with 4. It gives you the first number. So a1 is 4. a2, well, what do? It says you multiply by negative 2. It says to get any number, take the number that comes right before it and multiply by negative 2. Well, if I want this number, then I need to multiply this number, which comes before, by negative 2. So 4 times negative 2 is negative 8. And then you take this number and multiply it by negative 2, and that gives you, what, positive 16, right? To get the next one, you multiply this by negative 2, and that gives you negative 32, and then you multiply this one by negative 2, and you get positive 64. So that's it. That's the first 5 terms. Thanks for watching.